welcome Forward Networks for our first session. Josh Prokes will talk to us about doing more with less, how intent-based networking will fundamentally transform your enterprise network. So Josh, I'm gonna ask you to turn on your camera. I'm gonna say a few words here to Josh. Josh is the Regional Sales Director for the Southeast region. Josh has a strong business and technical background. He's a Cisco network specialist and has established C-level relationships within Tier 1 SP and enterprise community. He joined Forward Networks in 2020, and he's going to share the journey with us. Josh, wonderful to have you with us. Look forward to your presentation.
Wonderful. Thank you so much for the introduction, Jose. And good morning from Atlanta, everybody. This is Josh Prokes with Forward Networks. So, folks, I'd like to start off a little bit about, as Jose had mentioned, how is intent-based networking going to fundamentally transform the way you manage your enterprise network? So what I'd like to do today is give you a bit of an introduction to our company, explain it is what is it we do, and more so kind of define what intent-based networking is, because like most definitions, when you look at the acronyms of IBM, they're kind of meaningless unless you put some context around that. So let's get underway. And first thing I'd like to do is give you a little bit of an introduction to our company. So Forward Networks has been around for about 6.5 years. We've now been in market in production environments for the last 3.5 years. And our company was actually founded by 4 PhD computer science grads from Stanford University. So we think they're kind of smart. During their time at Stanford, a lot of the body of the work that they did was in the software-defined networking space. And they worked underneath the tutelage of Nick McEwen. And for those of you who are familiar, Nick McEwen is kind of considered the father of SDN. Additionally, during their time at Stanford, they did a lot of work with another gentleman named Martin Casado. And Martin was actually one of the co-founders of a company called Nicira, which later became NSX, aka VMware. And so, as I mentioned, we've been in the market now for about 3.5 years. And since coming to market, we've rounded out our leadership team a good bit with added members of leadership from the marketing side, the go-to-market side, as well as our product line management and our development side. So to date, we're a C-Series funded company. We've raised approximately $70 million. Some of our major investments come from the folks at Andreessen, Threshold, formerly DFJ, for those of you who are familiar, along with A Capital. And one of our premier investors, some of you may know, is Goldman Sachs. So I'd like to make a little bit of an emphasis on Goldman Sachs. They're a pretty interesting case for us. So Goldman Sachs was actually a customer of Forward Networks for approximately a year. Currently, they have a little bit over 15,000 core network devices under the management of our software platform, which is known as Forward Enterprise. And so over the year that Goldman ended up putting their entire global network underneath our care for intent-based networking, around that same time, they came to us and said, "Yeah, you know what? We really like what you're doing. We're trying to accomplish something you've managed to succeed at doing, and in fact, we want to be a part of your success." So Goldman Sachs actually did our C-Series funding for us and invested their own $35 million into Forward Networks because they indicated they wanted to be a part of our success. So just a little bit of a background on us, and let's go ahead and get into a little bit of how we're seeing the world, particularly the enterprise networks, and why we think intent-based networking is going to be a fundamental paradigm shift for the large way a lot of enterprises end up managing their networks. So as we look at the current state of network operations today, it has become vastly complex, right? We would even argue that it's outside of the scope of any single person or any group of person within your organization. You're having to contend with dozens of vendors, Cisco, Juniper, F5, Palo Alto, just to name a few. You're having to deal with thousands of different devices, right? The implementation of those devices, the configuration of those devices. And as I mentioned before, when I talked about Goldman Sachs and their global network, the approximate 15,000 core network devices they have underneath our platform, that really consists of switches, routers, firewalls, and load balancers. So in addition to the dozens of vendors and multitudes of devices, You've got dozens and dozens of different rules, different operating systems, different firmware. And fundamentally, what we just try to illustrate is that the management of these large heterogeneous and in some cases hybrid networks. And for those of you who need a little definition about the hybrid side, you may have either physical network functions, basically a purpose-built box as a load balancer, or you may have a virtual network function. And some of these things may reside in your data center or in your branch locations, and some of them actually reside in workloads in the cloud. So as we look at the culmination of how networks have exponentially gotten more complex, our four founders went out on the mission and saying, guys, there's got to be a better way to enable these enterprise networks, the function and the ability to manage this properly and in a lot more efficiently than what's been done in the past. So to kind of further illustrate that a little bit, this is the world that your network engineers and operations live in. They live in the CLI world, right? And so most times when people are working through either pushing new applications out into your network, different services, kind of your layer 7 folks, right? Or the folks who are working your front lines in your network operations centers, you know, as they're working, God forbid you experience an outage or some type of disruption of your service. This is the world that they basically live in. It's the CLI world, the command line interface, right? And so when we look at how people are having to effectively operate these networks, we felt that there was a better way to do it. But first, there's a couple of things you really need to know to be efficient in running your networks. And so effectively to operate your network, you really got to know what you have in your network, right? What devices do I have sitting out there, right? Then you need to know how it's connected, right? And ultimately, if you know those two things, you want to know where is all my traffic going, right? And so if you get those three things pretty tight, you also want to know whether or not is it working as I intended it? Is it working properly? And then as you collect all those things together and you start looking at your change windows, right? When you're doing upgrades or migrations of workloads, or again, pushing new applications into your environment, you need to know what is it do I need to change? And when I make these changes, am I causing any harm to my network, or am I exposing any type of security vulnerability, right? So some of these change windows that a lot of folks do, they're very complex in nature. Some of them are short and brisk. Some of them are very arduous and serial in nature. And so as folks start working through this and we start looking at the size and scope of these networks, we're sitting back and trying to illustrate to folks that, guys, this is just way too complex. So how do we help solve for that, some of that complexity? Well, I'm going to talk about that here in just a little bit, but I want to give you an example when we talk about the exponential growth that networks have experienced and why they're so inherently complex now. One of the examples I'd like to give is an example of a Fortune 500 company that we're working with. It's actually one of the three largest banks here in North America. Their logo colors are red and blue, so I'll let some of you guys figure out who that might be. But today they have approximately almost 13,000 core network devices. And remember, core network devices are those switches, routers, firewalls, and load balancers. So when we tell people, you know, you've got 13,000 core network devices in this massive network, how many lines of code and configuration are you guys having to deal with on a day-to-day basis? It's a staggering number. It's almost 3.3 billion with a B lines of code. And this is configuration information and state information. And so when you look at this heterogeneous hybrid network, and you look at the massive amount of information that your network engineers and operators are expected to manage, they're doing this while managing hundreds of change windows a week. They're doing it while they're managing over 500 different model and firmware combinations. And again, this is specific to this particular financial customer that Forward Network serves. And so as we go and explore in the value of intent-based networking, the network issues basically are still the same, but now you're dealing with this greater level of complexity. And so what we figured out at Forward Networks is that a fundamentally different approach is needed. And this is kind of why we believe intent-based networking, and particularly verification and assurance, is going to be critical to the future of networking. Because we believe if we do this right, there's some business value in it, right? And the three pillars of business value that we tend to see is that we give enterprise and operators the ability to reduce their cost, right? Reduce their cost from an OpEx perspective. We also have the ability to increase agility, right? So now instead of when you start looking at putting out new applications or services to your end users or your B2B partners, right? There's a lot of things that typically have to happen to ensure the posture or the readiness of your network is suitable for putting that service out. So we actually give the ability for folks to increase their agility, right? Their go-to-market. We actually shorten that time. And then the third thing we do is we de-risk operations. If you know exactly how your network is configured, if you know exactly how it's positioned and postured, you're going to be able to de-risk your operations, because now fundamentally, as you go through your change windows, you're going to know that as you make these different changes and configurations, or as you roll out these new services, you're going to do that with a lot more confidence than wondering if maybe my segment of network 6 or 7 hops away is going to be able to carry that traffic. And my customers, whether they're on one side of the world or they're located here in the United States, they're also going to be able to access that data and that information as seamlessly as somebody who might be in Singapore or London or Sydney. So again, as we kind of go through this, one of the things that we do at Forward Networks is we strive to improve what we consider to be operational abstraction, right? Because as I mentioned before, this is essentially the world that your network engineers and operators are living in, the CLI world. And again, this comes with a multitude of vendors, a multitude of different configurations and implementation of these devices. You have a wildly heterogeneous network. And I would almost bet that regardless of your business, a lot of you pretty much have a lot of the same vendors and same network core network devices in your network. So what we do is we actually take this information and we normalize it. We give a single way of looking at this where it doesn't necessarily require a 10-year CCIE veteran or JUNO-S veteran. And so we're going to explain that a little bit more. But let's talk a little bit about what intent-based networking is. So when we talk about intent-based networking, we're talking about what exactly is it that you created your network to do? Because we would argue that the two most important things to your business, number one, are your people, right? Whether it's the people that work for you or the people who consume your services, right? So your customers. But the second most important thing to your business has to be your network. In fact, it is the lifeblood, especially now as we're experiencing an unprecedented global pandemic, right? Your networks are the digital fabric that are effectively the web that is holding society together. So we kind of look at that as the essential digital fabric, right? And so when we start talking about the intent of your network, I guarantee you, most of you have firewalls, load balancers, or switches, or routers. But the way you designed your network, the way you've implemented your network, is going to determine exactly what is it intended to do. So, for instance, one of our other customers, they're a pay transaction company. You may have heard of them, PayPal. So we actually provide the intent-based networking platform for all of PayPal's network. They've got close to about 7,000 core network devices, right? And so the intent of PayPal's network, right, obviously, is to allow payment transactions and different ways to exchange funds and services, right? So the intent we get to is, do I have the necessary posture of my network, and how do I verify it? How do I know that site A and site B is connected properly, and that I'm allowing the proper traffic to ingress and egress through my network? Right, but maybe you're a retail store, right, and you've got multiple chains across the world or in a particular country, right? You want to ensure that your payment systems, that your retail transaction systems, that you have adequate redundancy, that you've got adequate bandwidth, that you're essentially positioned to take on any of all your services. All right, or maybe your intent is I have a production environment, but then I have visitors that come into my environment that also leverage my network. And so how do I ensure that I'm protecting myself as I have visitors that come into my network and utilize certain resources that my own employees would exist? So again, when we start talking about intent-based networking, I like to add a little bit more clarity to that, because fundamentally there's two different types of approaches right now in the market. And I would like to stress that intent-based networking is more a methodology, not so much a standard, but again, it's a philosophy. It's a new fundamental approach to managing these wildly hybrid heterogeneous networks. So if you look at the left side of the diagram here, you have something that is called intent-driven network configuration. Now, one thing I like to emphasize about intent-based network configuration is that this is typically something that's done in an environment that's primarily greenfield. And realistically, it only represents a very, very small segment of the market, right? So these types of designs that require intent-based network configuration are very, very specific. And more often than not, they're required to be homogeneous. So you're really kind of looked at a vendor lock situation. And so because that tends to be a little bit more, or in lots of ways, a significant, a smaller segment of the market, we decided to go to the other side of the paradigm, which is the intent-based network verification and assurance. So this is where we decided to participate. Because with the network verification and assurance, this really addresses what's also called brownfield environments, right? And brownfield environments are basically any network, as I mentioned before. Hybrid could be a combination of your network residing on-prem, or you could have also some other components of that sitting in the cloud, whether it's Microsoft Azure, GCP, Google, or AWS. And so we decided to participate in this space because the majority of networks today, right, are heterogeneous. And they have a multitude of vendors, the different firmwares we mentioned before, different operating systems. And so we felt that the biggest impact would be done here on the network verification and assurance side. So a lot of folks say, Josh, you know, this sounds really interesting and really cool. How real is it? And more importantly, how do you guys actually do this? Because what we've attempted to do is something that's been needed in the market for quite some time. I myself actually was a former network operations manager for a large tier 1 enterprise. I've also done that for tier 1 service providers. And I can tell you, if something like this existed about 15 years ago, I probably would have some more hair left. So let's talk about this a little bit. So the platform that we have provided to the marketplace is called Forward Enterprise. And again, the 3 pillars of this and the business value that we try to extend to our customers is, again, the ability to reduce their costs, right? To increase their agility, right? So your digital transformation objectives, right? And then the other one is de-risking your operations. Because again, nobody likes to shoulder outages, and certainly nobody likes to end up in the funny papers explaining why they were down or why people weren't able to process the payment transactions or access different services. So let's go back a little bit to what we mentioned before about the challenge to be more effective in your network operations. And so we discussed some of the 5 things that are really needed, right? Knowing what you have, how it's connected, where is all my traffic going? And when you got all those 3, again, is this stuff working as I intended to? And if it is, wonderful. Now, how do I determine what I need to change? So one of the things that we did as a part of our platform is we developed a set of tools, right? Network engineer, if you think about the day in the life of your most basic network engineer operator, right? Again, they're living in these worlds of the CLI. So how can we help them be more effective and more efficient? So one of the things that we do is we've created a wonderful tool called Search. So imagine if you had the ability in this wildly heterogeneous hybrid network to go in and perform a Google-like search on your network. Say you wanted to look and say, I want to ensure that I'm postured correctly across all of my firewalls and that I've mitigated any potential security vulnerability that may exist. Well, you actually have the ability now to go in and query those firewalls, and you can check to ensure that your gold standard has been applied. And it doesn't matter what the vendor of that firewall is. Again, whether it's Checkpoint, whether it's Cisco, whether it's F5. So again, we found that this is a very, very powerful tool for a lot of network engineers and operators to quickly identify the posture of their network and to ensure that their gold standards have been implemented correctly and that there isn't any violations. Another feature that people use in this search is, you know, from time to time, vendors will come out and they'll say, hey, we discovered a security vulnerability. And for those of you who have this particular network device running this firmware or this operating system, you need to do a scrub of your network and you need to ensure that the latest and greatest patch has been applied. So we also give the ability to quickly search your network to determine what's your exposure to that, what is your liability to that. And again, we're agnostic to the vendor, so it really doesn't matter to us which vendor it is that has those security announcements or vulnerabilities. We give you the ability to locate those quickly and to ensure that your network maintains good security posture. So one of the other tools that we provide within this platform is Verify, right? And going back to, again, Verify, now I'm able to search my network. How do I verify that everything is working as it's expected? And how do I have the ability to continuously validate that my network is postured correctly, right? Again, going back to security and configuration sanity, making sure that your best practices have been implemented and somebody hasn't fat-fingered something on a keyboard somewhere when they're working in that CLI, because that absolutely never happens. That actually happens a lot more than people probably want to admit. But again, we felt that this was also a very powerful tool that we give folks the ability, again, to go back in and ensure that not only can they search their network, they know it's there, but now we can continuously validate to ensure that I haven't exposed myself to any vulnerabilities. And then the third program, or I should say third application that we built also was Predict. And again, one of these things that we talk to a lot of our enterprise customers about is, I'm about to make a significant change to my network. I'm about to roll out this new service that's going to give our customers a much better experience, but how do I know that when I implement this change, that it's going to work not only in the segment of the network I'm working in, but it's going to be accessible to anybody who's trying to reach that application. And so what we do is we actually give you the ability to simulate some of the effects of the proposed changes, so that when you go in and you push those services or those applications, or you migrate those workloads, you can do so with full confidence. And so now folks tend to ask me, well, Josh, this is really awesome. How do you guys actually do that? So I'm going to talk to you a little bit about our platform, which is Forward Enterprise. So as mentioned before, really the purpose of intent-based networking, and particularly intent-based networking verification and assurance, is it does require a fundamental new approach to network engineering, network operations, right? So as we talked about before, you've got this wildly heterogeneous network infrastructure, right? You've got a combination of devices that sit on your prem. You've got some that sit out in the public cloud. We support AWS along with Microsoft Azure. GCP is coming towards the latter part of this year. But so now you have all of these different devices, different operating systems, different firmware. So what we end up doing is we go into your network and we create a mathematical network model, or what we call a digital twin. And this digital twin is a 100% accurate, precise mathematical model of your entire network. Now, one of the things I would like you to pay special close attention to is that little comment there that indicates header space analysis. This is very important. I'm going to talk about that here in just a second. So we go in and we collect all the information. We collect all the state and config information of your core network devices. Again, your firewalls, your load balancers, your switches, your routers. And so how do we collect this information? Well, we actually get that information from you. So one thing I want to emphasize is that Forward Enterprise is an API first driven architecture, right? We are able to actually consume your device information. It can be done via API through your CMB. Or one other way we also do this is we can SSH into your network via TACACS or Jump Server, or directly into the device itself. Now, one thing I'd also like to emphasize is that we sit actually in the data plane. So we're in the do no harm space, right? We don't actually push configuration changes. We essentially collect all that config and state information of those core network devices. And as you recall from the previous slide, one of our large banking customers, they had over 13,000 core network devices. That's where that 3.3, almost 3.3 billion lines of code comes from. That is all the config and state information of all of their core network devices. And so then when you take all of that information, we culminate that into a core mathematical network model. And then here's the thing that we like to give people. I apologize for that. We like to give folks is the ability to verify where their data is going. Remember, we go back to what's the most effective way to manage your network. You got to know what you have, how it's connected, and where your traffic goes. Well, one of the key features within our Forward Enterprise Network is that header space analysis that I mentioned previously. And so what that does is we now have the ability to not only give you this digital twin of your entire network, but now we can tell you where every data packet on every device, on every port can possibly go. That's right. Every possible path that data can traverse your network. So what does that actually look like? Well, when we talk about the problems that we tried to solve, folks, you got to understand this is a very, very heavy lift, right? We're trying to solve the ability for everybody to understand what their network behavior is, right? We also want to give everybody the ability to do this at scale because scale is very important. Today, we're right around about the 50,000 core network device instance. We're able to do that on a single VM. And again, we do this. We can either have this platform that resides on your prem. Some people require that as a part of their security, or we can also host this in the cloud as a SaaS. But again, the ability to scale, to be able to analyze all these different heterogeneous network devices, right? A single, and then actually provide instant access to all of your network behavior. And this goes back to the applications that we built, the search, the verify, to predict. What have I got? How are these changes going to affect my network across these multitudes of devices? And how do I verify that everything that I'm doing is keeping my network in its correct posture, right? So how are we doing? Where are we at today? So we have a very wide and deep matrix of support for multiple operating systems, device features, vendor types, right? We have the ability to essentially process all this information. If it's something that you put on a prem, you can do that on a generic COT server. It's about 10 grand. It's pretty cheap. But then one of the things when I talk about that header space analysis, I just want to give you a little bit of a perspective on that. So if I go back to one of our other customers I mentioned before, which is PayPal, and they've got almost 7,000 core network devices. When we went and did the path analysis, the combinations that come back, it's astounding. It's an exponential number. It's 10 to the 27th power. So what we're talking about is a combination of every ingress egress path on your network. And what does 10 to the 27th power look like? Fundamentally, it's about 10 billion times the number of grains of sand on every beach on this planet. So you have to ask yourself, how is it that my engineering and my operations folks are able to keep up with this? How are they able to quickly isolate faults or changes in my networks that either may be causing a degradation in service or may be impeding my ability to put out different services or applications? So this is why we incorporated the header space analysis. And by the way, the header space analysis functionality was actually the master thesis of one of our co-founders. You can find it on the web. It's only about a 152-page dissertation, so I would encourage you to read it at your leisure. But one of the other things that we also thought was really important for this, other side than the ability to do the search, to verify, and predict, is we actually provide a really intuitive GUI. It doesn't require a whole lot of training and management. It's about as easy as using an application that's on your phone. So again, when we start looking at the scope of the networks that people are trying to manage today, going back to the complexity of it, the multitude of devices, the multitude of operating systems, you know, the nuance of you may have somebody who's very, very fluent in Cisco, but maybe not so strong in F5 or Checkpoint or Palo Alto, or perhaps the gentleman who's responsible for a particular segment of your network is on vacation this week and something comes up and you need their assistance to verify either a segment of the network or particular devices as you're going through your change windows. Well, what we've done here at Forward Networks is we looked for a way to take the complex and essentially simplify it for your network engineering, network operations teams. So as you go through with your digital transformation initiatives, you have absolute clarity and confidence that your network's posture is correct. You have the ability to verify it with regards to pre or post change from change windows. And you also have the ability now to analyze it in fairly quick fashion as to whether or not all the traffic is able to reach these different services and applications that I have out there, because especially for some of you from a financial perspective, right? Every bit and packet counts. So I appreciate giving the overview to you guys. Hopefully you found that fairly intuitive. One of the things that we do like to do is we invite folks to visit our website at www.forwardnetworks.com. And we're also happy to provide you a demonstration of Forward Enterprise in action. And then we also have the ability to share with you some of the use cases and customer success stories. Again, as we've been deployed today, as I mentioned before, to Goldman Sachs, one of the top 3 banking institutions here in the United States, PayPal. We have several different government entities, along with various tier 1 service providers. So that concludes my presentation and my introduction to Forward Networks and intent-based network verification and assurance. And I would be welcome to any questions that you may have. I'll do my best to answer them.
Very good, Josh. Very good. Thank you for your presentation. I had some questions come in here as you're speaking, which you had a pretty technical component to your presentation there, and it's good to know that people around the world are awake and paying attention and asking this very specific questions. One of them is a bit broader, and it's more about the talk a little bit about the business case for this approach to networking, and how are you validating the business cases for that? What are some of the metrics that you look at, and how do you translate that into dollars for the business case?
Excellent question. Excellent question. So we typically tend to find a couple of recurring themes. Again, with our large Fortune 11 or Fortune 100 companies, whether enterprise or their service provider. One of which is what folks call MTTR or MTTI, and that acronym means mean time to resolution or mean time to innocence. So again, going back to part of the presentation where we indicated that most of your network engineering operations folks, when they are tasked with a trouble ticket, when their problem comes in, they're usually going right into the CLI, and they're having to check device by device, hop by hop, and they're having to log in and log out and actually manually do a lot of keyboard punching and swivel chair work to do that. And so that usually takes a lot of time. And so what folks, when they come to us and they say, hey, how can you guys help us improve our mean time to repair? Or in the case of mean time to innocence, let's say you've got a third-party business partner that utilizes your network and they're having a problem. So mean time to innocence is basically being able to say, hey guys, look, we checked the posture of our network. We know that our configuration and our state is correct. We can access and we can verify all ingress and egress of data. So effectively, guys, it's not us. You need to check your end. So that's kind of a proving of the posture of your network. So that's what they refer to as mean time to innocence. And when you start looking at that, a lot of folks keep their metrics, like they keep their historical data as they're working trouble tickets. And sometimes trouble tickets will take anywhere from 4 to 5 hours to be cleared out. Sometimes they go a little bit longer, depending on the complexity or severity of the condition. And so what folks have found with us is by having the ability to actually perform Google-like searches of their entire network to verify path analysis that traffic is flowing in and out of my network properly and haven't caused an issue, we've actually seen a reduction in mean time to repair and mean time to innocence on average by about 50%, and for some of our customers, 70%. So from a basic troubleshooting and isolation, there's been a huge savings from an OpEx perspective and also man hours, but also mitigation of SLAs, right? So SLAs come typically with some pretty hefty liquidated damages depending on the severity or condition of the outage. And so a lot of customers now have said, listen, if we had this, we went back into the historical analysis of some of our trouble tickets, and we found that now 7 or 8 times out of 10, had we had Forward Enterprise, had we had the access to our digital twin, had we know the exact posture of our network, we could have mitigated these in record time and actually avoid infractions of SLAs and the current liquidated damages. So that's one of the things. The other thing that we find is when you start working with your layer 7 folks in different companies, the ones who are pushing out these revenue generating applications or services, oftentimes these folks are having to go to network engineering or network operations and say, hey, can you validate that this port is open and available on this firewall? Or do I have these ACLs correctly defined? Because I'm about to turn this application loose. I want to make sure that one, it works and folks, all my customers can access them. So again, how can you validate that my network is in a position to consume this application and service, and more importantly, that my customers are? And in some cases, and this is an unfortunate reality, there tends to be a lot of what we call push and pray, where I think my network is right. From what I can tell, the testing that I did in my lab, which is a small microcosm of my network, and there's only so much you can validate, right? It's not like the production environment. But even with the best intents of taking these things into your lab environment, even though those all come out green and thumbs up and it's a go, everybody knows when you go into a production environment, you always expose corner cases. A network in production is under a different load than what you would have in a lab. So by basically being able to validate how your network is postured through the snapshots that we provide through our network, through the mathematical model, through the header space analysis, they can know definitively that as soon as I roll this new service application out, that it's going to work. So those tend to be the two biggest things that people look to us for. And then the third one is going back to doing more with less. Unfortunately, especially with COVID, right? We've all seen it in the news, right? Folks are getting furloughed. Unfortunately, people are getting laid off. But most people's networks aren't getting smaller. In fact, they're probably getting more utilized now than ever. And so now if I'm having to look at a reduction in my staff and in my headcount, how do I continue to manage all of these massive networks if I'm now expected to do it with a reduced staff? Well, that's when technology comes in. That's where the technology comes to help you scale. So we actually give folks the ability to do a lot more with less by letting the technology augment some of those other operations and some of those functionalities that people typically use from a swivel chair or perspective. Jose, I hope that question for you. And if it doesn't, I'll do my best to readdress it.
No, very good. That's very good. Other question that has come up is how long does it take to well, this may be a little complicated because you probably have different sizes of networks, different types of networks and complexity levels. But if you could paint a picture of maybe on a typical network, what is that process like? How long does it take to build the digital twin and to have it operational? Just kind of again, on a typical application, what does that process may look like and how long does it take?
Okay, so I'll get it in short order. So we have some customers that move very, very rapidly. Like I indicated before, with Forward Enterprise, it's a software platform that can reside in the cloud, right, as a SaaS, or it can reside on your prem. There is a component that always resides on your prem, and that is actually the collector. So our collector is what goes out and basically parses all the config and state information. And it's a very lightweight software package. You could actually even run it from your laptop. I could run it from the laptop I'm on right now. So that typically resides on a Linux machine. You'd stand up a VM, and then we would go into your network again, read only, right? Do no harm, collecting all the doing show commands, print commands, and collecting all that state and config information, and then combining that, and then that information is fed up into Forward Enterprise, which then does the numbers crunching to build the mathematical model, the digital twin. So to give you an example, probably one of the best ones I can give you would be let's use PayPal as one of ours. Again, they've close to 7,000 core network devices. They move pretty quickly for us. Getting the VM stood up, putting the collector on the VM, it's fairly simple to do. You can do that in about a day. And then we start collecting, we start parsing. And oftentimes we've seen it go as fast as 3 days. In PayPal's instance, we did it in about a week. And then once you actually collect it, so we call those snapshots. We go in, we get state, we set config, we build the digital twin. And the way we tell folks is we're going to give you a high fidelity, right, an ultra high def view of your network. And so we tell them, as you go in and you collect this information, as we create this digital twin, your first snapshot is like about a 720p if we talk about high definition, you know, folks are familiar with high def TV. So the first one you're getting is going to about 720p. Around the next snapshot, you're going to get about 1080p, and about the third snapshot, you'll be at ultra high def. And what we do is we take all that information in digital twin and we curate that network for you, so it resembles maybe some of the Visio diagrams that a lot of people tend to work off of, some of those logical diagrams, and we present that in a GUI in such a way that it's very, very easy to consume. Again, with our friends at PayPal, that took us about a week to do. And then the really cool thing about the header space analysis, remember I talked about that 10 to the 27 power, you know, how many different combinations, where can all of my data possibly go from this hop to that hop to that? But we can do that header space analysis after we have curated work. On average, 10 to the 27 power, it takes about 15 minutes. It's pretty powerful. It's pretty powerful. The larger the network, the initial time for, you know, we've got other networks right now that are running over 20,000 core network devices. The header space analysis on that will take maybe about 30 minutes. But again, as more snapshots are taken, the higher def network becomes, and then you're at state. Then you look at that as your single source of truth, and you don't necessarily have to worry about whether or not I've missed a network device, or maybe there's a port somewhere that I wasn't aware of that was operational. That's basically captured in the digital twin that we create.
Very good. And we have time for one more question here, Josh. This one comes from Antonio Urquiza, and Antonio says, first of all, he says, great talk, thank you. And following up on the digital twin solution that you just talked about, he's curious that from a cybersecurity perspective, how do you prevent your digital twin solution from becoming a single point of vulnerability for the client? So can you talk a little bit about digital twin and vulnerabilities and cybersecurity?
Yeah, absolutely. So the thing I want folks to remember is when we're talking about intent-based network, remember we participate in network verification and assurance space. So we're not actually we do not perform any type of configuration changes. We don't push down any, there's several different devices and manufacturers out in network today that do that. Typically there's things like network orchestrators. You think about Juniper Contrail CSO, or you think about Cisco NSO, or Blue Planet. So there's several different platforms out there that actually push configuration changes. What we effectively do is we create that high definition map, if you will, of your entire core network. And so that information, again, can reside on-prem. We do have some customers that for their security, they require that information actually resides on-prem. But even if somebody were to let's just say capture that information, which they can't because all of this is kept and it's encrypted, you don't have the ability to really change anything. But we'll tell you, it is sensitive, right, and proprietary, because now you don't want somebody to know. Maybe you have another competitor, right, another competitor who operates in the same vertical that you don't necessarily want them to know how you have your network configured, right, that your network is actually working better or is performing more efficiently. So that's really where that information is pretty sensitive. But as far as the ability to inflict or cause any damage or harm to an operator's network, that does not exist. Again, we sit in a data plane. So we're only capturing the information of what the current state and configuration of your network is, but we're basically giving you the entire map, the entire scope of that, for you to have the ability to go in and validate that as of today, as of this snapshot right this second, I know that my customer's data is going to flow. I'm not having any disruptions. My firewalls are positioned correctly. My ACLs are positioned correctly. And if I make any changes to my network, I'm going to have a reference. I'm going to have a single source of truth to go back to and say, okay, I was working before, something changed last night. What's the difference? Why am I now experiencing this problem? And instead of having to dial back in and do that CLI work from hop to hop, now they can go back and they can reference this. But again, so our tool here for folks in these heterogeneous networks, these hybrid networks, is the ability to know exactly what they've got, exactly how it's connected, and exactly where traffic goes. But as far as causing any ability to go in and manipulate, GP routing tables or load balancing rules, none of that exists. All that control and all of that all that access still remains with the operator. We do not provide that.
Thank you. Josh, thank you very much for taking the time to be here with us, to share your expertise. I mean, show us the depth of what's happening today in terms of optimizing networks, and that's fantastic reveal. We appreciate you taking the time to share your expertise with us. Thank you very much.
Thank you for having me, Jose. I really appreciate the time, and I wish everybody stay healthy and stay safe.
Thank you. All right, ladies and gentlemen, this closes our segment of our first segment for today. Our next presenter comes directly from the UK, and Dr. Arthur Prokes is the Senior Business Architect for Digital Transformation at HSBC, and he is going to be talking to us about customer-driven digital transformation. So I look forward to seeing everyone back at the top of the hour and emerging into the digital transformation that HSBC will share with us. So thank you. I will see you back soon.